So thanks for coming along. I think we should have probably set up in presentation format rather than forum format. But anyway, so tonight is all about Allstar. All things Allstar is what it's labelled up as. So we've got a little bit of a presentation, and then we'll open it up for people to go through what they've brought along, and then obviously questions as we fly through. Please throw them in, and we'll try and answer them as we go through. So we will get underway. So just going to put back here, club room share, and head over here. So all things Allstar. Over to you, Hayden, for a bit of history.
Yeah, so Allstar's been around for a little while, and I wrote up a brief history here. It's very wordy, this, but you can have a look through this back on the stream or have a look at it a little bit later on. Basically, Allstar was sort of conceived by Jim Dixon, WB6 NIL, who's now Silent Key, and basically he wrote a module called, or an add-on called app_RPT, which connected to Asterisk, which is a PABX, for being able to dial telephones together, basically. And what it originally was is for a repeater controller, so that they could connect repeater controllers and link radios together over voice over IP. So they experimented with different hardware, and then eventually they moved to the USB sound fobs that you see around. And then they moved on gradually as they progressed throughout the life of Allstar, I suppose. It became then a massive network. After Jim passed away, they created a public node system, which anyone could create a node number and set up an AllstarLink node so that they could connect to any other node across the entire world. So it's, in essence, what Allstar is. It's basically a bunch of computers sitting there, connected all via Asterisk, a bit like a telephone, and you can dial any one of those, or you can dial multiple ones at the same time and have a conference call. And then basically that telephone connection then interfaces to this app_RPT add-on, which gives us all the radio stuff that we can then interface to it. So basically, yeah, it became this organisation. It's got a board, non-for-profit, and it's completely customisable. It can be a repeater controller, a simplex link. You can connect all sorts of different devices to it, and the audio quality is really, really good and completely customisable, basically. And it's open source as well, so it's constantly in development. I put another slide in next, which confuses a lot of people about the difference between AllstarLink or VKLink. And the key is that piece that I just said about being open source. VKLink is basically, I think is the right terminology, a fork off of what AllstarLink was. AllstarLink has basically public node numbers that are set aside on the public system so that anyone can connect to them. You can create a completely private network using the technology that is AllstarLink, completely separate from the public system. So what VKLink is in essence a private version of AllstarLink, specifically for Australian nodes to sit on. So the idea is that these nodes would be able to connect to Australia only, so that we could link repeaters across Australia easily. At the time when it was done, which was I think about 2014, you couldn't really run Allstar on a Raspberry Pi very well. It was a bit clunky. There was a lot of code that wasn't really needed. You kind of needed like probably a machine like what Dale's got there, different type of PCs. So the idea is that we wanted to put it onto a Pi. So Matt, VK3VS, basically reworked thousands of lines of code, got rid of a lot of stuff that he didn't need so that it would work on a Pi 2, I think it was. And then we interfaced that to radios and repeaters and got it going, and VKLink was established. So all of the VKLink nodes are on private node numbers between 1,000 and 1999. They're the actually, I don't know whether 1,000. I think 1,000 is included. So that's the private sub. So essentially, we can have 1,000 nodes. Yeah. On the private network. So basically, yeah, VKLink and AllstarLink are pretty much the exact same thing, with a few differences that AllstarLink now is a lot further ahead of VKLink as far as development and features, but it has the same technical DNA in the background. You can, if you have an AllstarLink, register it to VKLink as well. So you can connect if you've got an AllstarLink node already, you can connect it to VKLink, and then you can connect to these private nodes. However, you can't do it the other way around. You can't connect VKLink to register it to Allstar. And later on, I'll show you some dashboards and things that you can view to see all of the nodes around Australia and how you can connect and do all that sort of stuff. So that's my bit. I think you're up to your next slide.
Well, we probably covered this in the key thing here is it's an ability to connect nodes together using VoIP technology, so voice over IP technology, and the engine to do that is Asterisk, and it's all open source. That's the key thing. And there's a table that great table that Hayden put in at the end of this presentation, which is the comparison between Allstar, IRLP and Echolink, and what are the key differences between them. And can I just say, one of the key differences is it's all open source, whereas IRLP is not. Echolink sort of is, but yeah, the key thing is it's if you want to get in there and start hacking code, go your hardest. So yeah.
It also allows for development too. So I guess in this particular, AllstarLink is very in depth. There's the very simple nodes which will show you, like the Shari nodes that you've seen, but the underlying engine that is AllstarLink is very, very in depth. There's a lot of things that you can do in it, and it means that they all run on things called channel drivers. So your channel driver is essentially your connection to the outside world, to your hardware. So they require constant updates and bug fixes and changes. So with it being open source, people can go in and actually work on this and then submit it to the main AllstarLink repository to be included in updates and things like that.
We'll include all these links in the video description as well. So because there's a lot of great documentation that's out there at a variety of levels. So absolute beginner's guide, which is what I used. Behind Lance there is yet another version of an AllstarLink node, which is the VK4 NGA node, which we'll go into in a few slides' time. But I started with the beginner's guide. I am very much entry level into this, but it's working, and it works fine. And that's a Pi 3, I think. So yeah. Uses. I don't know whether you want to.
Yeah. So why would you use an AllstarLink node? Probably should have started off with that. So you can use it a lot of different ways. The way that a lot, I think, in our club. And a lot that you'd be familiar with is little simplex gateways or nodes. So you can set one up at home, connect to any number of different nodes around the world, your local repeater, your mate across the street, someone in the UK or America, same as IRLP or Echolink. And then you can use your handheld inside to be able to talk from your handheld to this out via the internet to the other end where someone has the exact same setup. So that's the most simplest way, all the way up to building an entire repeater system out of it, which is what we've got with Mount Wellington and also the 10 metre VK7 RHF repeater. They all use the same underlying architecture, underlying technical engine. I don't know how to explain it. So you can also use your phone, because it's Asterisk. You can use SIP clients to connect to it as well. So if you've got a SIP client on your phone, you can register it. You can use your phone as a radio, basically, to talk back to your node. This here is a radioless node. So there's no radio at all. This has just got a speaker, a microphone. It's connected to a Pi. So we can interface this into the system. So this is good for if you want to run, say, like an emergency setup. You could plonk this down on the desk and you've got yourself a gateway into the network. You could use this. I'm going to use this particular one at home to monitor my the Allstar repeaters. So I can do all of that. So yeah, there's all sorts of different hardware that you can use. It also integrates with DV Switch as well, which I haven't played a lot with. So you can connect it to DMR and D-Star and Fusion and all those other modes as well. It does have auto patch capabilities, but we're not allowed to use that here in Australia. So you can make phone calls with it. Yeah, it's pretty versatile.
So as an example, how's it being used for linking our repeaters? What's the application that's being used there?
We might go into that in a later slide, but the basis of that is that we have. No, I'll go into that in a later slide because that's a little bit higher level.
No,
but as far as so our repeaters here in Hobart are concerned, if they want to connect to Launceston, for instance, so Launceston basically has a higher power version of this sitting at the club rooms up in Entark. And then our repeater connects to it via the internet, and then it transmits our audio to Mount Arthur, and then hears the audio back from Mount Arthur, and then transmits it back to us over IP. So what we used to do is we used to link repeaters over RF, which required lots of radios, antennas, more space in the rack, different frequencies, allocations, licenses. Now we just do it all over IP, and you probably don't even notice now that it's gotten so good, unless there's internet connections are so good, the jitter's minimal.
Only thing you notice is the delays.
The delays, yes,
Yeah.
yes. We will get into delays. You do have those. Because it's an IP-based system, especially when you go to full duplex, requires time to process all of the information, and you have to introduce delays and latency for that. So,
cool. Okay. Okay, getting on to Allstar. There are many different, not configurations, many different products. That's probably a better way of putting it. Many different products out there. Most of them are Raspberry Pi based these days. Hayden said that the development's been going on such that you can run it on a Raspberry. I'm not sure a Raspberry Pi 2, but
no, it's probably
a 3 above.
Yeah, 3 and above is probably good. You can run them on a Pi 02W as well. I think the wireless one, the small little wireless one.
That's better than the 3.
Yeah. I think it struggles a little bit with the previous, not the Pi 2W, the 0. Yeah, I think it struggles a bit on that.
Yep. And so there's many different configurations. We're going to be showing you a list, and I'll put a list in the video description, and we'll show you some of the actual products in it shortly. But all of them and each of them have installation instructions, which is step by step. If you're not used to Linux, which a lot of people go, oh my God, this is too hard. Most of those guides are actually step-by-step guides, and you can work your way through them. even if you're not used to Linux or you're not used to that sort of operating system. So,
the other use case I just thought about too, because I thought about the guys down at the channel Menshed. They were struggling with reception of the repeater and being able to talk to each other via normal simplex. So what they did was they got and invested in a whole bunch of nodes all in their living room. So now they've all of a sudden got coverage. They're all connected via the internet and they can all talk to one another. So,
in fact, they might even be online. There's
Probably,
quite a few online. And for those that are online, we will be showing these boxes shortly. So actually showing them in the video. So we've just got the presentation to go through at this point in time. And most of these, so once you've done this installation, and we can show you this, there are web-based administration portals. So you can you go into the website, it goes to your node. You can then do some of the configuration. You can do the linking. You can do all sorts of things via the website, which is coming from your actual node. So so that's pretty much okay. This is so we'll just run through this list, and then I'll flick across to the camera so we can actually show some of these nodes. So Hayden, do you want to do a bit of a promo for the first one?
Yeah, I didn't bring a board with me. So
I've got one, but it's
it's in the box.
It's in the box.
So one of the things that Allstar is big on is it runs on two specific audio chips. So when you interface the connection from the actual Raspberry Pi to the radio is usually a USB sound card that you plug in, and you have to modify the USB sound card to include a transistor to push to talk your radio, and also a diode to take the signal in from the radio to know when it's receiving a signal, so your squelch or your mute or your COS, whatever you want to call it. So that you can, so that the Pi, the computer, knows when it's receiving a signal, and then audio obviously goes over the sound card. So all these is they just have that particular chip on that sound card built in, and this is inside of here. It's just a board that pops in on the top, which is all well and good for a very little small Pi. So for VK4NGA, VK Direct, he sells a lot of them, like the one at the back. Yeah. This one here is a Sherry node from Kits for Hams. I think, Dale, you've got one there.
That's a Chinese copy of the earlier one.
Yes. Yeah. And we found that there was a lot who wanted to build high-powered AllstarLink nodes. So these are only limited to like a couple of 100 milliwatts. So we designed a digital interface, which basically is the USB sound card, but with all the modifications already done to it. And then we developed a daughter board to plug into the top of that so that you can easily just plug in a radio like a Yaesu with a 5-pin connector on the back, and away you go, you're ready to go. Or you could roll your own and use any radio that you want. So I've interfaced it to a PRM80, and there's a couple of others as well. So that's what the Toad interface is. I don't know much about Node Ventures or hotspot radios. You might.
None. They were just literally what came up in the list. So, and can I just say that was the top 5 of that list. There are many more. And the top 5, we know a little bit about some of these. So so do you want to show?
And this one here, which is the this is a communications interface, the radioless one. This comes from a company called AllScan. David, I can't remember his call sign, N9 something or other. So he runs another application that connects into Allstar called AllScan. And he sells those products as well, but he does a whole bunch of different nodes. I think there's Masters Communications. They build little interfaces. So yeah, there's lots and lots and lots of options that you've got available.
Do you want to go through what's on the bench for our online viewers?
So that was the Sherry Pi, which is just a board that just plugs into the top of the Raspberry Pi here. That's the communications interface, which is radioless one. This is, which we'll go into in a minute, is a voter board. which interfaces with a radio, which runs on our repeaters. And then this is essentially the exact same thing. That there is the exact same thing as that, only it's a surface mount version and a commercial version. But yeah, I won't go into that too much until we've established the basics of what Allstar is, because that's a little bit more in depth.
And what I'll do here is just go to the back of the room. Dale, do you want to, if I can get this right? Okay. And it's all in reverse, so apologies. Okay. Do you want to go through what you've got sitting in front of you?
That's a radialist node. It's the second iteration that I built. The first iteration was a CM108 board that we heard about.
Yeah.
I think I destroyed 4 of them before I got to the working one. And but that's designed off David's initial design, which has got a preamp and a Class D audio out.
Okay.
And it's full duplex.
Yep.
It works quite nicely. You can actually be talking to someone on the repeater and you'll hear the repeater drop out, which is quite clever. But that's running on a Debian 12 light client, thin client.
Yep.
Mind you, it's not a thin client anymore. It's got 128 gig SSD in it. But anyway, this one's is a radio node. That's the early Shari node, but it's a Chinese copy. It's exactly the same, runs quite nicely, and running on a Raspberry Pi 4. But this one I had fail 2 weeks after I built the thing, and I couldn't figure out what on earth had failed, and it was the SD card. So I ended up getting a different box with a solid state drive in the bottom end of it. So it's got an M.2 solid state drive, and it's been 100% reliable ever since.
Yeah.
But the only mistake I made was using this. When you use this one, it runs off the server. It's using this one as a server. So there's only one port. So you've got to open a port.
Yep.
If you're using it in your home, you've got to open a port on your router to allow the AIX stream to come in.
Yep.
But right, this is the one I use on the broadcast on Sunday mornings. I basically connect to 606 on R2 and stream it into my HF transceiver. And it comes out beautiful audio.
There you go.
Yeah.
I love it. Okay.
It's
Fantastic. Thanks, Dale. Now, can I get Lee, who's sitting behind you, to hold up the box that's sitting next to you? So there's not... Oh, hang on, I'll zoom in.
I'll do that so you don't got a horrible face in there as well.
This is the VK4 NGA interface board. This uses, Hayden mentioned earlier, it's a bit like the Shari. It uses an 818 RF module. And in fact, I'll after this, I'll take the top off so you can see what's inside.
Is it do or?
No, so that is a daughter board for Raspberry Pi, and it has the radio and all of the interface and everything built in. So I effectively get to it via a that's coming from there. In the same way as my DMR hotspot, etc. I just change. I've got another channel and get to it via that. So that's yet another version. It does come from VK4 NGA, so it is actually an Australian company and they support it. The support's good, documentation's excellent, follow the bouncing ball, and you end up with a working node. So that's the VK4 NGA. Anybody? Do you want to show this?
I was going to make a comment. There's something about what Dale said that reminded me. CM108. Codecs. That's right. Audio quality. So with Allstar, you can choose different codecs, and they all have different levels of audio quality. So the repeater uses the highest that's available, which is ULAW. Uses different bandwidths and things like that. ULAW is the highest on AllstarLink 2. There is a new version of AllstarLink called AllstarLink 3 or ASL3. That actually has another codec in it, but it's not backwards compatible with AllstarLink 2. So you can get really, really good audio quality. It almost sounds like simplex.
These are both Allstar 3.
Yeah.
AL3.
And they sound really, really
AL3.
good.
ASL3.
Yeah.
I do have a question. Where does a device that I've seen floating around called an R1-2025 sit in? It's a. Have you heard of that? Do you know? It's supposed to be an Echolink, an AllstarLink controller that interfaces with your Pi. Is that any of that?
Probably very much similar to all of these things, just probably from a different.
Apparently, it goes back. It goes into the back of a like a Yaesu 7600 or something with a USB cable.
Okay.
So, okay.
Yeah, there's multitudes of interfaces
Right.
that can work. Yeah.
Another question. Are these devices, can they be portable in any way? Like if you were, I hate to say it, but if you're going on a holiday, could you take one with you and set it up in a location or something?
Work quite nicely if you share your Wi-Fi off your phone and connect like a wireless device to it. That's what I've done. I've brought it up here on a battery pack and just used my phone as a because
So they
it's
can be
difficult to
portable,
change the Wi-Fi on the fly,
Yeah.
and then not kill the device. But it does work. A lot of people do it in cars and so forth in the States. So yeah,
There is a limitation with that in that if you do just hotspot it, you can only make outbound connections. So because you don't have any port forwarding happening, you can't actually receive anyone trying to connect in. So you can. There are ways around it. So because 4G, 5G has double NAT, so you can't port forward. You can run something like Tailscale on the device, and then can dial out and use your house as an exit node, so that you can accept inbound connections. So there are ways around it, but out of the box, you can only make outbound connections, which is perfectly fine because if you're on the road and you just want to dial home, you can do it. So
It's probably worth mentioning a lot of home ISPs now are also CG NAT, double natted. So you can actually ring, certainly if you're on one of the big ones, you can ring them up and you can ask them for a non-double NAT connection, and they might charge you for it, but you will get it. Just give them a reason for it. But yeah, be aware that if you get problems, because I've got problems with Echolink, I've got his proxy.
The time is 8 p.m.
I've got his Echolink proxy to get out on Thursdays.
um,
How rude.
yeah, we won't go into like setup of nodes, but essentially you do need to basically port forward one port, which allows connections in to your node from the outside so that people can actually dial it. But that's all in setup guides. Tells you all about that.
Did you want to show?
Yeah, share that out because that leads into what Dale was talking about.
Is it? There we go.
So the conventional way of building a node like what Dale was talking about was using something like that sound card there, which is a cheap one from China. And if you scroll down, Justin, you'll see that this is showing one of the node, like how to modify it. So you need really small wire and you need to solder to that chip, which is on the board, which is okay if you've done it before, but you do wreck a few or you can wreck a few in the process. If you scroll down a little bit more,
By half a dozen.
Yeah, I think I've done probably about 4 or 5 of them now. So yeah, there's
I've done one.
yeah, and then that one the wire's actually running under the chip as well, and there's the transistor in that one, and that's the finished product. So you plug that into your Raspberry Pi, and then you've got your connections to your radio on the right hand side.
Okay.
So you've got PTT, mute, audio in and audio out.
No
but
cos. No.
yeah, mute, yeah,
Mute.
COS,
Okay.
yeah.
Okay.
But there
Okay.
are
They're getting very hard to get now too, and there's a lot of later boards which hasn't got the same chip on it,
yeah,
which masquerades as one of those.
yeah, and it doesn't work.
and it doesn't work. no.
Yeah. Yeah, that's right. There's a lot of fakes out there too. So you can't just get any old sound card from like China and do it.
When I was building them though, the only reason that you're doing that modification is to get your, I've forgotten if it's a DTR or RTS lines, because
Yeah.
they're not exposed.
For PTT, yeah.
Yeah, but there's nothing stopping you just getting a separate USB adapter that exposes PTT and RTS.
Mm.
They don't have to be on the same board, because the audio dongle is effectively just giving you your audio. And if you want to have a separate dongle that gives you your RTS or DTR, like that works just as well. So you don't actually need the special audio one.
Yeah.
I can't remember if app RPT can access 2 USB devices at once. I can't remember. Did you actually get that working?
Yeah. So that's
maybe
how
it can.
that's how I have mine running on my what's the PMR?
Oh, PRM80, yeah. Yeah. But it is still hard to get some of those dongles, the CM108s now. I think the CM119 also works. That's another chip.
Now I just use the cheap Chinese audio dongle, as long as there's a driver for it on Linux, and
Which usually it's just plug and play. Usually,
Yeah.
just plug it in and it works.
I just don't think it's as complicated. It doesn't need to be as complicated as it used to be. Now.
Yeah, and then what Paul was talking about was people have made entire interface boxes to just plug into a radio and away you go. So you don't have to go and homebrew your own if you don't want to.
Okay. Any other questions for? All right. So what we'll do is I'm flicking around here. Do you want to do a bit of a demo or?
Yeah, I might talk through that.
Okay.
So the original purpose of AllstarLink was to build a repeater controller, basically. So everything that is in AllstarLink, you go through the config. It's all built around building a repeater controller, which controls everything that you could ever need in a repeater. So what we did was a couple of years ago, I purchased about, I think 5 or 6 of these PCBs. I got these made up at PCB Way, I think, and they weren't populated. So I populated all of the components on this board and did about 5 of them. It took me quite a long time. There are some components that I didn't populate because I didn't need them. And what these are is, I mentioned earlier that you've got channel drivers. So you've got the ones which connect simply in with the USB connection, but then you've also got another channel driver that then talks to these boards. And then these are just a radio over IP interface. So these just connect to a radio. And the sole purpose is to control the radio using this board and sending all of its audio and information back to the Raspberry Pi. So we've got a few of these on around the place, on Mount Wellington, Grey Mountain, a few other places. And what these do is these are called voter boards. So these take the audio in real time from each receiver on those repeaters. It sends them all back at once to the controller, which is the Raspberry Pi, and then it evaluates which signal is the strongest. And then what it does is it then sends that signal or that audio stream from the Pi back to these boards and to the transmitter that's on at each repeater site. So then that way, as you're driving around, you're switching between whichever receiver is actually picking you up the strongest. So these are the brains basically behind the repeaters that we've got, and this is just a little surface mount commercial version. These are like $500, I think, to buy. They're not cheap, so I've only got 2 of these. I think that's why I built these. I think these are about $200 to build. And this was designed again by that guy Jim Dixon, who was the brains behind Allstar. This, like, if you've ever thought about smart people, this guy's like top level smart. He's just, boggles my mind how smart the guy was. So he designed this board, and this board was designed in 2011, and that gives you everything that you need on it. Connects to a GPS, and he also had forethought when he designed this to do simulcasting as well. So he didn't, I don't think, had time or didn't really test simulcasting. He just put it in there so that someone someday would actually do it. And it probably took about 5 or 6 years until a couple of us around the world started experimenting with simulcasting. So we're probably, I don't know, there's probably about maybe a dozen simulcast systems around the world that I know of that run this, and we're one of them. And it works pretty well.
So for those who don't know, explain simulcasting.
2 transmitters on the exact same frequency transmitting the same audio at the same time, so that when you're listening on your radio, you don't know what transmitter you're hearing. So then you can create one big massive repeater coverage area on the same frequency.
Southern Tasmania.
Yeah. So at the moment, Mount Wellington and Grey Mountain are the 2 transmitter sites. They've also got 2 receivers at those sites, and then there's additional fill-in receivers here at the Domain and on Mount Lloyd to cover the coverage. We do have a couple of coverage holes. One's the outlet, and we're going to fix the outlet with the repeater site at Broughton Avenue that we're working on. And yeah, essentially we could create one big repeater for the whole of Tasmania if we really wanted to. And they're all connected over IP. The 10 meter repeater, that works in a similar fashion with 3 of these around Hobart receiving 10 meters. So you've got diversity, diversity reception. So if someone, say on the mainland, is talking through the 10 meter repeater, they might fade out of one site and then they go into another. And then they fade out of that and go into the original one. So it's really cool. And you can view all of this on the dashboard. I don't know if you've got the dashboard up, but you can view all of the real-time signal strength. And yeah, it's crazy the amount of stuff you can do with it.
What's the 10 meter transmitter site?
10 meter?
Yeah.
It was at the college, and it's currently being rebuilt at home. But yeah.
No. Okay.
Simulcasting. The timing needs to be pretty much spot on. What are you using for timing on them?
GPS and 1 pulse per second. So all of the sites have a GPS with a 1 pulse per second sending to these boards. So the boards know exactly what time it is. And they send their audio and data frames every 20 milliseconds. So there's a 20 millisecond chunk of audio and data that's sent multiple times, over whatever time period. And then when it arrives back at the controller looks at all of that data and then evaluates, okay, which one do I need to send out? All times, all sent at the same time. And even over IP, it's amazing it actually works.
Fit and latency.
Yeah. It probably uses about, I don't know, 20 gig a month or something like that. Because it's sending. It also has a control data stream to know that it's there, to keep like a keep alive packet.
Yeah.
It's amazing how long, when you've got a keep alive packet running 24/7.
Yeah.
How much data that actually uses.
Yeah.
It uses quite a lot of data.
What do you do? What happens when the internet goes down?
They
still work?
Yeah, they have a fallback built in, so this can operate independently of the internet. So it'll just go into basically a dumb repeater mode with no connection to the outside world. So you can still operate through the repeater. It just doesn't have the internet. However, what we do have with our network is we have our own private IP links to the mountain at the moment, but we're working on the other sites so that we don't rely on the internet. We just rely on a private IP link.
Cool. Okay.
So there's a lot of infrastructure to run this system, but yeah. I did a whole presentation on YouTube for the club like a couple of years ago, I think, on this. So if anyone's interested, they can go and watch the presentation, which talks more in depth about the repeater stuff. Yeah.
And we'll put the links in the presentation. Integrations. Hey, did you want to talk to this?
Yeah. So we touched on integrations earlier. So Echolink, there's a native Echolink channel. So if you've got an Echolink node, node. Echolinks don't have nodes. Echolink number. You can. It's been years since I used Echolink.
They call them Echolink nodes. But
Yeah. So you can put in your Echolink node number into Allstar, and it's like if anyone knows what an interrupt is, it'll directly talk to Echolink. So someone who's on a computer with Echolink can talk directly to your Allstar node if they want to. We already mentioned auto patch and SIP and all that sort of stuff. Mentioned the voting and the simulcasting, so there's that integration. There's lots of web control and monitoring. So the main one is Allmon. So at the moment, I've got Allmon 2 running, which runs the voting stuff. So you can use that to connect, to disconnect, to see the status of what's connected. We can bring it up afterwards as well. AllScan is the other one that I mentioned that you can install, and you can basically create a favourites list of all of your favourite nodes that you've connected to, and it will show you in real time which ones are keyed up, which ones are the most used, and you can connect to them instantly. So they're like dashboards, basically, status dashboards. And then there's all the digital integration as well. So there's a lot.
The latest version, you can actually have multiple favourites files too.
Yeah, or
So
for AllScan.
Yeah. That's their latest
Yeah.
change.
Improvement.
And it's good because it's got like a little heat map thing. Well, it's not a heat map, but like a colour. So the darker shade of red indicates that one's used more often than sort of the other ones.
Okay.
And it will automatically sort like to the top the ones that are currently keyed. So if you're sitting at home and you're like, oh, I wonder who's on the radio today, you can bring up your dashboard and go, oh, this one's active. You can connect to it instantly and join the conversation. The public, there is a public list of public nodes, so you can search through all of those. You can search by call sign. You can find where they are. You can see which ones are active.
Which ones are keyed? Actually,
Which ones are
there's a
keyed.
keyed list.
Yep.
As well. So
you can always find something to listen
Yeah.
somewhere.
Yep. Cool. Now here's the comparison file. So key things to point out.
Echolink's sort of proprietary. Doesn't have as many integrations. IRLP is pretty much its own standalone beast. Whereas AllstarLink's completely open and integrates with everything except for IRLP because you can hack it, but the restrictions on the IRLP end. AllstarLink allows RF nodes, PCs, mobile, all sorts of different pieces of hardware. I'll borrow that. Whereas Echolink sort of apps on your phone or PC. You can create RF nodes though using Echolink as well, and IRLP is RF links only. Linking models are pretty much reasonably similar in the way that they run. AllstarLink can cross network to pretty much everything. Echolink can go to AllstarLink, and IRLP is pretty restricted. The advanced stuff, the only thing is AllstarLink with the voting, and the typical uses there down the bottom. So AllstarLink can be used for a lot of things: repeaters, links, remote bases. I think there is a way of setting up remote radios as a remote base that you can control as well, using AllstarLink. So yeah, they're pretty much the comparisons. They're similar. They're all VoIP. They all run over the internet, but there are some pretty big key differences between them all.
Couple of questions. What's the difference between 2 and 3? So,
as in AllstarLink 2 and 3.
Allstar, yeah.
So
Main difference.
so there's AllstarLink 2, and then there's ham VoIP, and then there's AllstarLink 3. The main one that everyone uses is ham VoIP, which is essentially the previous version of AllstarLink 2. About 12 months ago, I think, they released, it might be longer than that, might be a year and a half. 12 months, yeah. They released AllstarLink 3, which is a major rewrite of AllstarLink. It's like 10 years worth or something worth of coding, fixing, bug fixing, feature improvements. I don't even know off the top of my head what half of it is, but it's all documented. But it's basically a major rewrite of the whole software.
Okay. You said there was some funky audio stuff going on at the moment.
Oh, well, we discovered, when I say we, Dion, VK7DB and myself, we discovered that AllstarLink 3 is doing some weird things with audios. Like, he migrated a node from ham VoIP to AllstarLink 3, and then all of a sudden his audio levels dropped on the nodes, and then couldn't get them to go up again, and we can't understand why. And then he reverted back to ham VoIP, and still couldn't get it to go up. So we're like, well, is it an AllstarLink 3 issue, or is it a hardware issue? And we're not quite sure. But yeah, and then we did a second one, and AllstarLink 3 did it again. But yeah,
and that's a good segue into where does ham VoIP fit in this picture?
Yeah,
that's the question from the
so online. I guess the way to think about it is AllstarLink's like the official supported, not the supported, that's the wrong word. AllstarLink 3 is the official software. Ham VoIP is another fork off of AllstarLink with certain modifications and changes. Ham VoIP is closed off, which it shouldn't be, which has rubbed some people, I think, the wrong way. It works fine, no problems at all. But yeah, it's just another side venture.
It's another fork.
But they all talk to one another.
Yep.
Yeah.
Okay. Cool. All right. Questions?
Does this system improve the resilience of the repeater network? Because with the Simulcast, if you drop one repeater and it's got coverage from another repeater in the area, you still get service there, wouldn't you? So, are there any other advantages like that? You know, what's the difficult part of the whole operation of all rolling over?
What's the hardest part about Simulcast?
No. About when you're operating this network.
Oh.
What will take it out, and doesn't allow you to keep it going? Like, you know, if you drop a link out, like an RF link, you've only dropped that link.
Yeah.
So where are the critical points, the choke points, if you like?
Pretty much the IP links that are based on the internet.
Yeah.
So if the internet connection goes out, then it's a problem. The difference, though, with what we've got running here specifically is we've got our own private links, IP links. So, you know, most of them are battery backed up, so they won't go offline generally. And the internet ones are directly connected in a carrier to a carrier's network, so they're not supposed to go off either. But yeah, if the internet goes off, that's the biggest issue. But then it can fall back to its own standalone mode.
No Optus, huh?
No, it's not Optus.
Yeah, no 000 on this. Now
that's actually a good thing. I wonder whether auto patch would be legal if we actually managed to be able to patch it so it could dial 000 in an emergency. Interesting. It could get abused though. That's what I could see.
I know, correct.
It would be handy.
We're actually allowed to run encryption as if it's part of emergency services. That's part of the revised LCD. If you've read it.
Oh, you can also run. Not on the public AllstarLink node network because that's only for ham radio. But if you wanted to set up a private node completely independent, you could do that on CB radio now. So you can do that UHF to UHF 27 megs to UHF 27 megs to 27 megs. And actually got clarification from ACMA about that today.
Cool.
And or commercial. You could put this in a commercial system if you wanted to as well.
Okay. Now, Dave, VK7CB, so that's a good segue as well. Hayden and Dion were doing some funky full duplex stuff this afternoon.
We were.
Was that AllstarLink?
Yeah. It was. So there's different modes. There's when you configure your node up, you configure it as either a simplex node or a connection to a repeater controller as a repeater, or you can have full duplex. So this particular box can run full duplex. So essentially you can pick up the microphone, hold the PTT down and speak to someone while still listening to them like a phone call through the speaker, which is really handy for doubling because you know what's going on.
Doubling.
You can also use it for situations where if you need to be able to monitor and hear someone else calling whilst you're in the middle of a transmission, you can do that as well. Doesn't work very well if you've got a speaker sitting here and then the other person you can also has a speaker and you can hear them at the other end because you will hear yourself coming back. So you basically have to wear headphones.
Is there echo cancellation in that?
No, there's no echo cancellation built in. Not that we've only just started playing with it. Not that I've seen.
The advantage being you can tell someone off for interrupting you.
Well, we were talking over one another, and anyone listening on the repeater, it probably would have sounded like we were sharing a microphone in the same room.
In the same room.
Yeah, but it's pretty cool. You can do. It does time announcements. It does date announcements. I know Lance loves those. It does weather announcements as well. Here in VK, the weather announcements are very basic. It'll do temperature and
Wind or something.
Something like that. But in America, you can
National Weather Service.
NOAA. So it'll integrate with NOAA and it'll do tornado warnings and storm warnings.
Yeah.
So you could be listening on your repeater and all of a sudden a tornado warning gets issued and it'll broadcast it out, which is really cool. You can also play broadcast files directly. So you can submit the broadcast to it and it will just play it out.
It's an audio
Once you've converted it from MP3. Yeah, there's a lot of stuff.
Can you set it to block certain connections? I was just thinking about the example you gave of the hams down in channel area who don't have reliable access to RHT, and you said they sort of set up their own little node network. If you're in a situation where you had one of these nodes but you don't want outside people dialing into your node, so you want to use it for the outgoing connections you want to make, do you have the ability to block them?
Yeah, it's got a whitelist and a blacklist.
Okay.
So you can configure whitelist nodes that are the ones that you do accept and it will block everything else. And blacklist nodes accepts everything except for the ones that are on the list. It's not perfect because, there are ways around it, but it works 99% of the time.
And there's a question, would it be considered okay instead of PSTN being illegal, so a patch to the phone system, could you auto patch Ham Shack hotline instead?
Probably, yeah.
That's outside of the RF domain, so yeah, most likely yes, because you're actually keeping it out of the RF domain.
Auto patch is an interesting discussion. I definitely don't know the legalities of it here in Australia, and you'd probably be able to challenge it because the whole point of the connection to the public telecommunications network was taken away officially in the class license. But for years, hams have connected like the radio to the internet. But the main purpose is just to keep unlicensed people off of the network. But if you've only got a one-way connection that dials out and you've got someone on the other end who's not an amateur, but are you supervising them technically? They're not broadcasting over RF. They're coming out over RF, but they're not broadcasting over RF. But are you supervising them? I mean, I don't know. It's in America they just auto patch is fine.
Yep.
I mean, people don't just go making phone calls over the air because it's all public, but it's good in emergency situations.
They used to.
They used to.
Andrew asks, is the tornado warnings just limited by what you can do with the Asterisk integration? Or is it an integration outside of Asterisk integration?
It's a NOAA thing. So NOAA have a public, I don't know what the system is. It's not an API. It's a
Public broadcast, emergency broadcast system.
It's a thing that you can subscribe to and they'll push it out for you. It's used for a multitude of things, but the Bureau just doesn't give us anything like that.
Oh, and the Bureau are resource constrained at the moment.
Yeah, the Bureau have pretty much nothing. I think the only weather stuff that we have is it'll read weather stations at airports and it'll give you the temperature at the airport.
Okay.
You used to be able to, before they changed the model, the Wonderground. Wonderground used to have an API thing that you could connect to.
Because that was one of the options you could select.
But now they charge like $500 to use that or something. So you can't use Wonderground either.
Just a note on Hamshack Hot. I think Hamshack Hotline's now shut down.
It has.
Yeah.
Yes.
Okay.
Yes.
That's at the end of August.
Any other questions? Please throw them in.
Should we dial up a node and listen to something?
Yes, please.
So we can listen to the audio quality. Now, because I don't have any port forwarding going on here, I kind of have to do a bit of a workaround via home, but I can do that. Let's find something that's currently being used. What's the roundtable net? That should be running.
Arthur's roundtable.
Yeah, that should be going.
Yes. That's usually happening on around about now.
I should be able to connect
See,
to
that's
that.
been dropping in and out.
Oh, okay.
Yeah, that's been.
So last Wednesday it dropped out. The
Yeah,
week before it was alright. The week before that it dropped out.
yeah. I
So
just
it's come on for a little bit and then
I just tried to connect to it and it didn't work. I think that's political.
Oh.
yeah, I think there was a
Okay.
bit of stuff going on there.
Yeah.
Radio politics?
What sort of radio do you need to drive the system? What's your originating source? There got to be a digital radio, analog,
Standard analog radio.
Well, and truly, it's an analog
FM.
MD380,
Yep.
which they don't make those anymore. There's MD390, I think.
Yeah, it's still made.
They are still made.
The
Okay.
only difference is the MD390 is waterproof.
Okay.
So I can tell
standard
you
amateur frequencies.
Well, and truly, this is originally I bought this for DMR, but it's an analog radio as well, and it's an analog channel that talks to the hotspot and talks to my.
Hotspot is 70 cents.
Yeah. Well, and truly.
just need a handle on 70 cents.
It's quite good for analog as well.
Sorry.
I've had good experience with analog on them as well.
That's what I. For those people who are on the 23 centimetre net on a Sunday, that's what I'm talking on.
What about going the other way and attaching the radio to the node itself with the antenna, so you've got bigger range around where you are to get in? So what radios doesn't matter for them either?
Well, that's for. I haven't had any experience of putting something else on there because I haven't needed the greater distance. But
Sorry, I wasn't listening.
no, increasing.
CMS is running. We should be able to connect to them.
Oh, maybe they're watching. Maybe we can wake up Bob and Greg. RF boosting the RF out of the hotspot. You had any experience with that?
No, you need an amplifier that also does transmit receive switching as well. I haven't done that. No, probably possible.
I'd go with a better antenna to start with because those aren't terribly efficient. The little.
But you can run a standard antenna.
Well, true.
Yeah.
Oh,
So you just bypass having a radio altogether and go straight from that to the antenna outside.
You
I
just
can
need to put
I can
on
work
some.
this from my driveway, and that's about it.
Yeah. And either put the node at the antenna or have some very good coax to get there, because it's fleet power that comes out of these things.
VK7H.
Good evening, Emily. VK3EDM, VK3UT. What's happening on your side of town, over?
So this must be this is coming out of CMS, whatever they're connected to at the moment. Have a look.
VK3UT, VK3EDM. I'm currently watching the two brainiacs of the household try and figure out a router. Hack around, whatever they're doing. But I'm watching the two brainiacs do that if you want to run some commentary with me.
Is that B1 and B2?
You must have just made a funny comment, Emily. They're laughing. Good morning, good evening.
Oh, so they're connecting to VK3 RWB and Warrnambool. And there's a bubble chart showing you all the connections at the moment.
Is that Ross?
No, I don't know who that is.
That's one of the things with the Allstar website. You can either have it as a list or you can have it as a bubble chart to see who's connected to what, and it gives you the node numbers of each and all of that sort of stuff.
So CMS is permanently connected at the moment to the Warrnambool men's shed.
Ah, that's what it is.
So that's what it is.
Yeah, because Bob was talking about that. That's what they wanted to do.
Get a men's network together.
Well, that's what they're doing.
But anyway, obviously getting it sorted.
There's two other men's sheds that are getting an Allstar node as well. So they'll have this men's shed hub. Pretty cool.
I'll give you a call.
So this is VKLink and all the VKLink nodes. Now, Paul, you asked earlier about a map. So VKLink has a map functionality which you can click here and it draws a map here of all of the nodes that are currently attached to
Are these sensed nodes or are these reported nodes?
These are reported nodes,
right?
That are active and online. So you can see there that there's a red line that's currently being drawn from Launceston to
that angle
VK6. So that's VK6 GC, I think. So you can see all of the nodes that are connected. Now, if you go back to the list of nodes, which is probably a bit hard to see, but you've got a description of them all. You've got their numbers here on the left. So all of these ones here at the top are VKLink only nodes. These ones here in the middle are restricted ones because they're on 6 meters. So they're only they're restricted to standard and advanced only. And the one down the bottom here, these are all of the AllstarLink nodes that are registered to VKLink. So these can talk to these top ones. The top ones can talk to the bottom ones. And then here on the right-hand side, you've got which one is connected to what.
Oh, yeah.
Now, if you drill down even more and you go to my Allmon page, you can go to a specific node. So this is the one that's on Mount Wellington or RHT, and you can see exactly what nodes are connected. So Bob's got his one connected to it. Tony AX up north, the Northwest Tasmania repeater group connected. Brian BW's connected, and VK4 GEO.
Oh, he's online.
Yeah.
So does it matter how many are connected? Does it appreciate the system in any way?
There is a theoretical limit. I think I've had like 60 nodes connected to one Raspberry Pi and had no problems. Obviously, with a network like this, you've also got to be very, like Harry's just joined. Harry joined the chat.
He's not here. Harry's sick right at the moment. That's why he's not here.
The other thing that you also need to be aware of too is that there's different modes that the way they connect. So these are all in transceive mode. So it means that anything that comes in on one node can go out the other node. So that means that any one of these that receive a signal can go out over RHT, which can be a problem if you're then connected to other nodes further downstream. So, for instance, if Harry's connected in transceive and he's still connected to those guys over in Warrnambool, their conversation will then come out on RHT. because they're in transceive mode.
Is there a loop arrangement that can happen?
So the system is smart enough that if there's an IP link, an IP link that tries to be established, it'll go no, you're already connected.
Right.
But if you've got an RF link, then you can get a loop, which has happened a few times. So it's very difficult sometimes to balance all of this stuff. Feel free to connect in, like Dale connects in every Sunday, which is fine. Just be aware that your node, if there's any problems, could lock up the whole system. So if you just want to log into monitor, then it's best to connect in monitor mode, not transceive mode, because then all you're doing is you're just listening that way.
So if you're connected in monitor mode, can you switch to transceive mode without disconnecting?
Yep. Yep. So there's a couple of ways that you can do it. So you can do everything over this type of dashboard and connect to other nodes using this. So if I actually log in with my credentials, which I probably shouldn't really share, should I? Let me do that for a minute.
Just talk among yourselves.
Yeah.
Password one. No.
So up here, I can actually type in a node number, and I can connect to another node. If I want to, just click connect or monitor or disconnect. There's also here a control panel where we can view all of the statistics of the repeater. So there's a whole bunch of stuff in here. You can see how long the repeater's transmitted today, 1 hour and 42 minutes. It's transmitted for 22 days, I think, since system initialization. Yeah, it does count for chunks. 1,202 total, 57 today. So someone's been busy.
Oh my God, someone's been busy.
There's all sorts of different things. You can force it to say the time of day and everything. The voting stuff, I can turn on and off transmitters. You can turn on and off voters. So there's all sorts of control in there that you can do. And this is the old version. This is Allmon 2. I do have Allmon 3 running, which is the newer, updated platform, which looks like that. Again, very similar look. And there's also a voter dashboard so that you can view the RSSI of the repeater in real time. So if anyone was talking on that, I'll show you this one because it's got better colours. If anyone talks on RHT, you'll see it light up there. I'm sure that someone's listening and will be able to give us a test. There you go.
That's me.
So green means that's the current voted station. Blue means that it's receiving a signal.
And it's dodgy.
And it will give you a signal strength 0 to 255.
And that's the diversity receiving.
Yeah.
That is showing there.
So you'll see the green will move between the different receivers. That's the current one.
Just the ones you're using.
Yeah.
That's cool.
And there's a whole algorithm behind this. See, Harry's full strength into the domain, but he's weak into Mount Wellington because he's probably on his handheld. So yeah, that's the dashboards. I don't have Allscan to demonstrate because I haven't got it running. So
cool. Making up a few ka-chunks. Eh?
Yeah. It's my aim in life.
Mr. Ka-chunk.
Oh, we're up to 62 now.
No more.
Yeah.
Okay. Any other questions?
I think the beginner's guide looks good.
Oh, you've got some stuff on that, don't you?
Well and truly. There's and I'll be putting the links in the video description with the beginner's guide. It is all in the Allstar. And can I just say there are many YouTube videos done by people on setting up an Allstar node and getting it working and all of that sort of stuff. So between the beginner's guide and some of those, including Ham Radio DX did a node from scratch video as well as other videos. So yeah,
Americans.
It's hot, it goes down, and it's smooth.
It's hot.
So now we're listening to this is a repeater in Georgia.
Okay.
Yes, sir.
This is the quality that you get.
It's hot, like your mother.
It's hot. Ah.
They have accidentally tuned the burners that make that stuff. That's right.
They don't say much, do they?
Quick over.
Them good old
Very
boys,
good
they don't have
taste.
much to say.
Very quick.
I'm just seeing whether anybody's commented.
In Georgia, oh my
We've
goodness.
got UK.
I'm not sure why,
And
but
New
it seems
Zealand.
like accents are amplified by like tenfold over a radio.
No, those aren't.
Yeah, Queenslanders who have forgotten about daylight saving.
No. That's the guys who put it down and roll it. Has nothing to do with me.
No idea what they're talking about. We might disconnect them.
Yeah.
Maybe let's go to Britain. It might be a bit safer.
I say, old boy, none of that rubbish on the house.
They'll only be talking about knives in Britain, I'm sure.
A bit of banjos in the background.
we got 2 ton of moonshine to move.
That's a good accent, Paul.
I have been infected.
Oh, the other things you can also do is you can do audio checks.
Oh yes,
Parrot.
Parrot. Yes,
So
yes. And local parrots, which is what I learnt tonight.
you can do local parrots. Wait for this one to do its thing. VK7HH testing 1, 2, 3, 4, 5.
Audio level is just about right. Okay, 7HH testing 1, 2, 3, 4, 5.
No,
And
really?
if you-
Okay, yeah.
And if you crank it,
Crank it.
VK7HH testing 1, 2, 3, 4, 5.
Audio level is very high. Okay, 7HH
I did say it.
testing
Oh,
1,
come on,
2, 3,
come
4,
Really
5.
I
shout.
might need
Yeah,
to.
shut it.
I might need to crank it a little bit more. How's that? 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Yeah, that's just way too loud. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Gotta have a sense of humor.
Yeah, it does. This guy, I can't remember his call sign. He set that up. It's pretty cool.
Tell him about the one where you really overdrive it.
Oh, it what does it say? It goes, whoa, my ears, or something like that. Or my ears are burning, or something like that. And then he's like, I think if it's too low, he's like, hello, are you there? Or something like that.
Oh, is that just a node that you connect to?
Yeah.
Oh, right.
It's,
So you set up his node as the parrot.
Yeah, it's quadruple 5-3.
Okay.
5-5-5-3.
Oh, cool.
And it just talks back to you. Yeah. And what I like about it is he's got that.
The
Feedback?
only thing is, you won't just hear your own.
No.
You'll hear other people testing their nodes as well.
If they're on there at the same
Yeah.
time, yeah. Yeah, there is a local parrot mode though that you can enable, which doesn't give you the same feedback, but yeah. So probably information overload, but
Any final questions? Have a look. Come up. Have a look. I'll take the top off that so you can see what's inside. And yeah. So hope it's been helpful.
Yeah, it's just been like we've been playing with AllstarLink for like years and years and years, and it's really good to see a lot of people now starting to embrace it and have fun with it. I think the AllstarLink Foundation, they run the servers and everything, the public servers. So they've I think since COVID, like 3 times as many nodes as they had before COVID. So it's really taken off, which obviously costs a lot of money for server uptime and resources and infrastructure. So if you do have an AllstarLink node, they do recommend, if you can, you don't have to, but it is good to just, throw in $10 or something, or a small donation on their website to keep the costs running. So, yeah.
Or even better, subscribe.
What's I assume you could spend $20 or $200,000 on this thing, depending on what you want to do. But what's the standard entry price to get up and running?
Dale's probably got a good idea. the different
Hard to
things.
say. I mean, this box cost me nothing.
Yeah.
Um,
If you got an old Pi
yeah.
doing nothing,
The all-in-one interface box that I mentioned to Hayden a little bit earlier cost me $30 off of Ali.
but these Sherry Pies come from the US, so obviously you got to pay for exchange rate and stuff, and these are like the high end.
Shipping is
the high end ones.
but shipping is horrible from the US right
Yeah.
now.
But then like Dale's got the Chinese one, which works just as well.
Yeah. And VK4 NGA.
Yeah.
So that's VK Direct. That I only bought the board. So I had a Pi. I only bought the board, and it was with shipping. It was just over $100.
So that's the hat. Is it
That's the hat
with
for
the
the
antenna
Pi.
on it?
So it's got the radio built in. You get the antenna. You get you have to configure the Pi. Go through all of that. But yeah, that was I think just over $100 with shipping. So to give you an idea, and they sell complete units, so you can buy the Pi and the hat and the inner case and all of that sort of stuff, and you're probably talking $200 to $220. It's that sort of figure.
Some places will if you register your node number, they'll
do it.
They'll pre-configure it and do it all for you.
Here's the password. Go for yourself.
What's the minimum Pi level? I've got an old Pi 2 at home.
Three and above. I
That's
think
all right.
is the minimum. And NGA says 3B and higher.
Okay.
So yeah,
Three as well.
They put two twos together.
it becomes a 4.
Now you're being silly, Rob.
Anyway, all right. Thanks.